A carbon or sulfur result that arrives after the heat has moved on has limited value, even when the measurement itself is accurate. In a foundry, chemistry data must support charge correction, inoculation or desulfurization review, grade confirmation, defect investigation, and release documentation. The analyzer is therefore part of a production control workflow, not simply a device that produces two numbers. Carbon influences matrix structure and hardness relationships. Sulfur affects machinability, inclusions, and the behavior of molten iron. When scrap streams are mixed, chemistry drifts, or a furnace sample is not representative, the same nominal alloy can behave differently. Reliable control begins with a representative drill turn, pin sample, or prepared piece that reflects the heat rather than a segregated surface. Preparation is a critical source of uncertainty. Oils, scale, moisture, cutting media, and cross-contamination can affect combustion results. The laboratory should define how samples are cleaned, sized, weighed, labeled, and stored. A stated sample mass of 0.5 grams can help estimate method setup and consumable use, but it does not replace a preparation specification. Buyers should confirm whether that portion is suitable for their cast iron, steel, alloy, or cement matrices, and how repeat samples are handled. The JIEBO CS996 is described with a 0.5 gram standard sample weight and an analysis time of 25 to 60 seconds. That interval is useful for understanding the instrument cycle, but it is not the same as total throughput. Sample transport, preparation, furnace loading, result review, cleaning, and repeat measurements must be included in the sample-to-decision calculation. A short detector cycle does not automatically create a fast release decision. Material coverage also requires verification. The product page lists carbon from 0.0001% to 10.0000% and sulfur from 0.0001% to 3.5000% with extended ranges described as possible. These stated capabilities should be tested against the actual grades and returned scrap streams in the laboratory. Request matrix-specific repeatability, detection limits, certified reference material recovery, and evidence for any extended range. The analyzer uses high-frequency induction combustion to oxidize a prepared sample in an oxygen-rich environment. The resulting gases are routed to infrared detection cells, where absorption is used to quantify the relevant carbon and sulfur-bearing species. Stable furnace conditions and complete combustion remain essential. A fast detector cannot compensate for a poorly converted sample. Calibration must be treated as an active part of the quality system. Low, mid, and high concentration reference materials help demonstrate response across the working range. Blank checks can reveal contamination or memory effects, while repeat measurements show whether operator technique contributes significant variation. Certified reference materials provide an external anchor for recovery, bias checks, calibration verification, and audit records. For the CS996, the stated configuration combines the analyzer with a WF-L88 high-frequency automatic inductive combustion furnace, low and high carbon analysis pools, and an optional high-sulfur pool. That flexibility may suit a laboratory serving several grade families, provided each matrix is linked to the correct pool, calibration, and reference material. The stated association with ISO 9556 for carbon and ISO 4935 for sulfur should be supported by documented method scope, calibration records, and any deviations introduced by the Foundries sample form. A defensible evaluation uses normal heats, samples near specification limits, and known difficult materials. Test them with at least 2 operators on more than one day. Record sample preparation, mass furnace program, analysis pool, calibration status, blank result, start time, approved result, and repeat reason. The final procedure should state which results are valid, which require repetition, and which trigger escalation. The strongest purchase decision connects chemistry to action. Each result needs a review owner, a response time, and a record that closes the action. Maintenance, training, consumables, service response, and backup testing should be defined before commissioning. The most valuable analyzer is the one that turns a representative sample into a traceable process decision before the next avoidable batch is made.